Welcome back to PPP. We were speaking about guidelines, the informal design guidelines that we use to form relational schema. We have focused on two guidelines in the past two videos, and now we are going to focus on how to follow the second guideline, eliminating insertion, deletion, and updation anomalies. And the way to do is decomposition. And let's just dive right in. Decomposition. Yeah. So whenever we have anomalies formed due to redundant data or poor schema design, what we have to do is reform that relation so that it makes sense. Okay, so that it makes sense. So that's where our friend decomposition comes in handy. So decomposition is we know normally whenever speaking of decomposition, yeah, we speak about decaying of dead bodies. Yeah, decaying of dead bodies. What happens to dead bodies? Well, they decay due to bacterial and fungi process. They eat the body little by little, okay, and break down the molecules that in the body into smaller, simple molecules so that they can consume. The bacteria and fungi can consume and produce energy. So similarly, here also decomposition has similar meaning, okay, but instead of dead body, okay, here we have dead relations, okay, decomposition, 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 and let's get this. So what is decomposition? Decomposition. So breaking down of large and complex relations into smaller, simple relations. This is what we call decomposition of relations. Well, if decomposition is done correctly, that is what we call normalization. Now you understand why we were studying about these informal guidelines. Okay, actually, these basic ideas lead to the bigger picture of normalization. I could have started with normalization like the zero NF, zero normal form, the unnormalized form, and then first normalized form, second normalized form, third normalized form, fourth, blah, blah, blah. But if you can't understand the ideas behind it, how we come to that normalization idea, well, there is no use in studying what normalization is. Okay, why we use normalization. So let's focus on decomposition now. Okay, so what is the purpose? As we already know, we are going to perform the guideline 2 here. Okay, follow the guideline 2 here. That was about reducing data redundancy. It was about reducing redundancy. Okay, for reducing redundancy, and we had to avoid anomalies. We had to avoid anomalies, and we had to protect data integrity. That's the main reason, to make sure that our original data stays original. That's why we need uh, decomposition and also storage efficiency. Okay, these are the four advantages that we receive from decomposing properly or normalizing properly. Okay, storage efficiency. Well, I have been talking about redundancy for a long time, but I have not actually told you why redundancy forms. Okay, well, what redundancy is, the same data is in the different versions. Different versions of the same data are stored in different places of a relation. That's what we call data redundancy. Okay. Well, why are this data redundancy formed? Why is this data redundancy formed? It's because if we put some attributes, okay, if we mix up attributes in one relation that are not even related to the primary reason, okay, the primary concept, okay. So redundancy forms Redundancy forms when attributes of different relations, attributes of different relations, I mean different entities, pose together in a single relation, in single relation. That's why redundancy is formed. Okay, so we can say these attributes do not relate naturally to primary logic or primary concept of relation. Okay, so this is when redundancy forms. So if we can separate these attributes into different relations, well, we can actually reduce data redundancy. Okay, and we know that data redundancy is the primary reason for data inconsistency. It's the primary reason for data inconsistency, and it's the primary reason for anomalies. Okay, and also the storage space is wasted. Okay, so inefficiency, inefficient, inefficient data storage, data storage. These are some of the drawbacks of data redundancy. Okay, you may think ஒரு ரெண்டு like if you have two or more three tuples more than wanted, what could happen அப்படின்னு. But if you consider large companies, if they have these large number of if they have this data redundancy, well, it will be not one or two tuples, it will be millions and billions of tuples. Okay, well, I don't know whether it's millions or billions. Well, it will be thousands, nearly thousands, or hundreds of thousands. Yeah. So for each one, if you think there is 1 MB, 1 megabyte of storage allocated for one tuple, think of it. If we have 100,000 tuples, it will be like nearly one. Yeah, it's nearly 100,000 megabytes. Okay, so it's like nearly 100 GB wasted. Okay, so that's why we should always reduce redundancy whenever we can. Okay, so what is the decomposition process? Okay, we can't decompose to our to எங்களோட ஆசைக்கு ஏத்த மாதிரி, to our desire. We can't decompose. We have to follow strict procedure. Okay, we have to follow strict procedure. Because if you decompose improperly, there will be issues like new issues. Already இருந்த issues சரி பண்றேன்னு போய் நம்ம வந்து we will create new issues. Okay, so for example, if you divide improperly, there will be if you join them back, okay, if you join them back, there will be inaccurate data that were actually not in the original data set. Okay, okay, that happens if you decompose improperly. And if you decompose improperly, there might be loss of data, there might be loss of data. So there are so many risks in decomposing, but still, if you follow a strict correct order or strict correct procedure, decomposition will be easy. Decomposition will be easy. Decomposition will be easy to do. Okay, so let's study about decomposition process. Let's study about decomposition process. So as we already know, breaking down of relation R into smaller two or more relations, obviously, relations. And when you put together these relations, okay, when you put together these relations, they should cover all the attributes of relation R. Okay, so you will be breaking down R into R1, R2, R3, R4. And if you study all the attributes in R1, R2, and R3 and R4, all put together, they should cover the attributes that were in the relation R. Okay, if relation R had C1, C2, C3, C4, C5, C6, Well, if relation 1 has C1 and C2, C3, if it has C2 and C4, and if this has C3 and C5, and let's say this has C2, C3, C6, well, this is a proper way of breaking down. Why? Together, they cover all the attributes in relation R. Okay, so that's very important. So together, these smaller relations, the smaller relations should cover all the attributes, all the attributes in relation R. This is the decomposition process. Okay, so what are the main things? Decompose relations should cover all the attributes in relation R when put together, and we should also have a way to put together. Okay, which means we have to have a way to join these smaller relations to bring back the original relation without any information loss, or well, we have to be able to put together and without any original data loss, or no data, new data should be formed when you are putting together. Okay, which means when you are joining this smaller relations, when you're joining back these smaller relations, it should result in R. It should result in R. Okay, it should not have any data loss. If C6 is missing, well, that's wrong. Or if you have some C7, well, that's also wrong. That's also wrong. Okay, and also the tuples. Okay, let's say in R there were 5 tuples. Okay, if you have only 4 tuples when joining together these relations, well, that is wrong. Well, then you have decomposed improperly. There are some specific names for that. That's what we call lossless join condition. Okay, I'll explain it in the guideline 4. Okay, if you have 4 tuples when you are joining these back together, well, that's also wrong. If you have more than 5 tuples, if you have more than 5 tuples, that's also wrong. It should be 5. 5 tuples இருந்தா 5 tuples தான் உங்களுக்கு வந்து ரிலேஷன் திரும்ப புட் டுகெதர் பண்ணும்போதும் வரணும். கூட குறைய வரக்கூடாது. Okay, keep that in mind. All right, so this is how you have to follow the guideline 2, which says us to eliminate data redundancy. Okay, and now itself I will teach you the guideline 3. Okay, it's not a big concept. So now itself I will teach you the guideline 3. Okay, guideline 3 is no null values. Okay, guideline 3 is no null values. Guideline 3, no null value. In a relation, it's not great to have null values in them. Okay, so the principle is design relational schema in a way that minimizes null values in the relation. Minimizes null values in the relation. Okay, so yeah, keep that in mind. And how can we do this? We can carefully structure the schema. Okay, carefully structure the schema, or we can well, and we can separate attributes prone to null values. So, for example, yeah, I'll explain it. Okay, so you can separate attributes prone to null values. All right. So the expectation, before we go to how to do it, we'll first of all learn about expectations. Okay, expectations is first of all we shouldn't have any confusion in interpretation. So we have to this helps us to avoid we have to avoid confusion in interpretation. Okay, and it's also useful. It's also main reason why we follow this guideline 3 is to make sure we have efficient data storage. So we can make sure we have efficient data storage, and we also can we also should be able to prevent. Okay, that was something. We should be able to prevent issues regarding query processing. Okay. Query process ஆகும்போது we should not have any issues. Okay. We should not have any issues. For that, we shouldn't have any null values. Okay. If you have null values, there is a high chance that we can end up with some issues. Okay. So decomposition is the only way here. Okay, as I explained it, for guideline 2 and guideline 3, decomposition is the only way, so that we don't have any null values in the relation. And you should know the reasons. Okay, you should know why some attributes are prone to null values. Okay, why are they prone to null values? Well, first of all, irrelevancy. Why? What do I mean by irrelevancy or irrelevant? Okay. See, some attributes are irrelevant in some relations. For example, if you have a if you have an employee relation, okay, if you have an employee relation in a school, well, that includes teachers and administration staff. Okay, and if you have a subject attribute, okay, if you have a subject attribute, well, administration employees have no values for that. They have no values. They have that tuple was that has the attribute subject is irrelevant for administration employees. Okay, so that's why we use is a hierarchy. Is a hierarchy to divide these two people. Okay, divide these two people. We have to break down more. Okay, that's why we use is a in EER. Okay, so this is one example. Second one is missing. It can go missing, which means maybe the data input person, the person who inputs the data, forgot to input the data, or if they did not input someone's data, register data. For example, in school, let's say there is a student entity. Let's say there is a student entity, and there is a phone number attribute. Okay, and if the data entry specialist did not ask the student's phone number, well, this is going to be null, and that's second reason. Third reason, unknown. Now, and the status unknown. Okay, status unknown. Well, status unknown currently means what about the grade? Okay, grade in a relation, in the student relation. Let's say there is a grade attribute. Well, that grade attribute can be entered only after the exams are finished. Until then, it will be null. Yeah, it will be null. So these are the main reasons why attributes can be prone to null values. This is inevitable in some cases. Okay, this is human error, and this is poor schema design. That's the reason. If we had the subject in only teacher column, teacher is an employee. If you have teacher is an employee hierarchy, well, then this problem won't be there. So that's what we are trying to focus on. Okay, this is human error. This we can't do anything about that. And status unknown currently is also nothing we can do about that. But this one, they can actually correct it. So that's what we are targeting here when decomposing relations into smaller and simple relations. So that's it for guideline 3. And we have focused on guideline 1, 2, and decomposition in this video, and also guideline 3. Okay, we'll look at guideline 4 in the next video. Thank you for exploring decomposition and informal design guideline 3 for relational schema. If this video helped, give it a like and share it with others. Don't forget to subscribe and hit the notification bell to stay updated with more database design lessons. I'll see you in the next video. Until then, keep learning and stay curious.
Bye bye.